Okay, before I begin, can anybody confirm whether my audio is fine and can you see my screen? Okay, fine. So I'll begin with the first question. So the first question is from GATE 2015 session 1. It is electrical technical question 22. So in the given circuit, the silicon transistor has beta equal to 75 and collector voltage is Vc equal to 9 volts. So the ratio of Rb and Rc is, so for the given circuit we have to find the ratio of Rb and Rc. So let us see how we'll proceed to solve with it. So the ratio between, it is a general formula, the ratio between the collector current and the base current is given by beta, which is mentioned in the question. So the definition of beta is the ratio of IC and IB. So that is given as 75. Now the next for the KVL in the collector loop, basically this straight line, if we take a loop from VCC to ground, it is 15 minus ICRC equal to VC, which is given as 9 volts. And ICRC by solving this question KVL, ICRC comes out to be 6. Now this base loop is important because there is no given data for that. So you should know the some assumptions that needs to be taken to solve this question. So VC will apply KVL to the base loop in this loop where RB exists. So VC minus IB RB is equal to VBE. Okay, so VBE, one sec, just give me one sec. Sorry for the interruption, guys. Yeah. So VC minus IBRB is equal to VBE, that is equal to 0.7. So this is the forward drop of the semiconductor which needs to be known to you. That's it. So this is 0.7. So if we solve this equation, we get two equations which were from the previous slide, that is ICRC equal to 6 and IBRB equal to 8.3. And one more equation is given to you in the form of beta, which is given as 75. So IC is equal to 75 IB. So if you substitute this IC equal to 75 IB in this question, where if you substitute IB as IC by 75 and solve this first two equations, you will get RB by RC as 103.75, which is the answer to this question. Okay, so it was a fairly simple question from mathematics point of view. Only the assumptions that were needed to know are VB equal to 0.7 and this formula IC equal to beta IB. If someone doesn't know the basics of the BJT, he would have lost on this kind of a bonus question. Fine. So any doubts in this question? Fine, fine. Okay. So I'll be proceeding to next question. So the given question is from the same year, GATE 2015 S1, electrical technical question 16. An inductor is connected in parallel with a capacitor as shown in the figure. So L and C is connected, and as the frequency of current is increased, the impedance Z of the network varies as. So as we can see, this is a parallel resonance circuit without any R. So we can directly write the as it is, they are saying they were talking about frequency here. So we can directly comment on that we have to do some frequency domain analysis, okay, of this circuit. So just give me one sec. Hey bro, don't talk. I'm in a live class. Yeah. So in this question, when you do the impedance, parallel impedance of this question, L and C, so Z is in the frequency domain, Z is equal to SL parallel 1 by CS. So therefore Z, if you do the calculations here, Z turns out to be SL upon S square LC plus 1. So if you see from this frequency domain equation, the magnitude of this plot can never go negative. Okay. However, the phase can. If you do some phase analysis in this, if you substitute S equal to j omega, but here they are talking about the magnitude plot. So as you can see, they might trick you with the negative impedance and in this question, but if you see from strictly magnitude point of view, the C is the option that matches that. But yeah, if you see from phase perspective of this question, like this, so this will be the question. So this will be the answer. So if you put S equal to 0, it will be 0, and S equal to infinity, it will be 0. However, at resonance, it will have some peak. But the magnitude plot of this frequency domain equation cannot go negative. But if you do the phase domain analysis, it can vary. It can go in negative or positive. But if you strictly limit yourself to magnitude plot, C is the answer to this question. So any doubts in this question? Okay, fine. So quality factor. Okay. So quality factor, it basically, if I have to give it in a short explanation, so quality factor explains you that the peaky nature of the this resonance thing that happens at the frequency of resonance. So how much this peak will vary up and down, it depends on that quality factor. So that is the short explanation. I do not have any mathematical content to show how it varies mathematically, but okay, in the next class maybe I can take it up and explain you in more detail the questions related to quality factor. So next session will be also on circuits, so I'll try to take the questions on quality factor. So if you add a R, the quality factor basically varies with that. So the peaky nature of the resonance waveform comes down. It's that. So that is the assumption of that. Okay. So let's take a last question for today. So this is a delta connection of resistors, and its equivalent star connection is shown on the right. If all the elements of the delta connections are scaled by k, the elements corresponding to star equivalent will be scaled by the factor of. It's a fairly very simple question. If you just know the transformation of this network into this, it is given by R. This is capital A is the star network and small is the delta network. So if you simply convert this network to this network, the formula is, I have shown it for only one resistor. So R capital A is equal to RBRC upon RA plus RB plus RC. So if the elements on the left side are scaled by a factor of k, the elements on the right will be scaled by a factor of k square. So that is the answer to this question. So this kind of bonus questions will come in the GATE exam. So make sure you revise your formulas for star and delta conversion. You can easily get 1 mark or 2 marks in numerical entries. That's it. So as this is the first week of the rerun of this NPTEL GATE course, I have started with some easy questions which I explained you. Okay, but going forward, me and my colleagues in the GATE portal, throughout the week we will be taking the questions. Gradually we will increase the difficulty in the coming weeks, and who have attended the previous run of this GATE course for the 12 weeks, they might know this. So going forward, we'll be hoping that you guys will join as frequently as possible. Fine. So for today, I had only 3 questions. That's it. If there is no question, we can conclude the session. Yeah, Kunda Patil. Does anybody want to ask a question? I'll wait for a few seconds if you wish to talk. Yeah, so session time is given in the Gate Mentoring Sessions portal. Gate Mentoring Sessions. So if you have to select again on like it is session, live mentoring sessions will resume from 21st November. It is for electrical engineering. You have to see for Wednesday. It is given as this. This was older one. This is the older one. This you have to scroll it across. Okay. So you have to see which day contains what. So and the meeting links are given in the rightmost tab. Okay. So like for all days it is given. So I can paste this link for you in the chat. Okay. So you guys can go through this. Okay, Sairam, Vignesh, you are saying. Okay, Sairam, Vignesh, you are saying first question. Okay. So yeah, someone is saying that the first question ICRC or IC plus IBRC. No, it will be ICRC only because we are talking about the collector region. Emitter is here. Emitter is IC plus IB. Okay, so that is wrong. You have said in the comment section. Yeah, so the first question for Sairam Vignesh, as you have requested, I'll explain it again. So this is the question where beta is given to us, beta is equal to 75 and collector voltage is given as 9 volt at this node, and we have to find the ratio of RB and RC. So what we do is assuming that you know the fact that IC is equal to beta IB and beta is given as 75, so the ratio between IC and IB is 75. We apply KVL in the collector loop. 15 minus ICRC is equal to 9 volts, which is VC that is given from year to year. Then ICRC comes out to be 6. From KVL in the base loop, from here, VC minus IBRB is equal to VBE. So this is the assumption that we need to know, which I have given in red. So VC minus IBRB is equal to VBE. From this VC to ground, we are applying KVL. So VBE is the forward drop of this semiconductor between base and emitter, that is taken as 0.7 volts, which is a standard electronic assumption. This is the important assumption here. Now from the equations given on the first page, we just solve them and numerically present them, and by solving these 3 equations, by substituting interchangeably, we find RB by RC is equal to 103.75. Okay, so that's it. So I hope Sairam Vignesh, you have understood what I was trying to say. Fine. So I'll conclude the session. You guys can follow this mentoring sessions. For every day it is going to happen, and we can meet next time. Fine. Yeah, Shubham Prajapati, you want to say something? Okay, fine. Maybe raise the hand.
Yeah.
Hello. Praveen Khade, I am confused between session timings. What exactly are you confused? I am not getting it, because it is given in the tab exactly. Wednesday 6 to 7 was my session. That link is given at the end of this row. Okay. Likewise, for every day, what topics were covered in the past and what topics are there. However, some will have some errors, maybe few, but more or less they will be accurate. So for Thursday, Friday till Sunday, it will be given the links. Okay. So just keep a track of this mentoring sessions. Okay. Fine. Thank you.